right? We saw different ways of marking. That's first thing that you should know. Number one, we use CoS bits. How many bits are for CoS? Can anyone answer? How many bits are for CoS? So 3 bits. I was telling you there are 3 bits and I have different probabilities. 7, 0, 0, 1. Totally 8 probabilities you have. In that, this one is default, which means no QoS. This is high priority compared to this one. And this is high priority than this one. And this, I'm sorry. So 5 will be here. This is 4. This is 3. And this is 2 and that is 1. So we have these many options to set priority level. After setting, if you enable QoS, I hope you are listening everyone. After marking this to a traffic, if you will enable fair queue, I'll show you in the configuration. I'm just giving you what you're going to see. If I straight away do, you may not understand because you've forgotten everything that we learned. If you have set this weight and then if you go and say fair queue on the interface, which means you have enabled weighted fair queue. Without doing all this weight thing, if you simply enable this on the interface, then also you have enabled QoS, but it is not weighted fair queue, it is fair queue, simply fair queue. When you say simply fair queue, depending on the session, for each session it will be giving equal amount of bandwidth. Whereas when you put weight, depending on the weightage, the amount of bandwidth, the prioritization level will vary. There is 2 types. With this marking, without marking. Without marking is fair queue. Same fair queue with this marking in the packet. We call it as weighted fair queue because you got weights, various weights, 7, 6, 5 weightage. Did you understand this too? So the next one is you match some traffic, say for example, voice, telnet and SSH and reachability, let's say ICMP, and you can set that same weightage CoS value, or if it is layer 3, you can use IP precedence, that is also same 3-bit, or you can use differentiated service code point. I hope you remember this word, DSCP. We saw which one will get dropped first, which one, AF31, AF44, AF43, AF42. I hope you all remember all those things. So if I give for voice as EF, expedite forwarding, meaning high prioritized. Telnet and SSH, because they are management, I want to give AF41. For ICMP, I would like to give, this is also for checking the reachability, important for troubleshooting, so I want to give AF31. This we call it as class-based weighted fair queue. For voice class, this is the queue, high priority queue. For Telnet and SSH, another queue, little lower than the above one. ICMP, much little lower than the above one, So DSCP has got 64-bit, so you've got more options to mark. Now all this you're going to see, but you will not be seeing a separate. I'll show you this, but I'll be doing what is there in the current network. Current network, what we have is this one, but for voice we will not be using a bandwidth command. When I use bandwidth or percentage bandwidth, what you're configuring is class-based weighted fair queue. For this, what I'm going to say priority queue, priority command, priority and then bandwidth, which means I'm enabling PQ. We learned in the last QoS class, PQ plus class-based weighted fair queue, together we call it as LLQ, low latency queue. This is what I'm going to show you. So when I show you LLQ, I will cover this one as well as this one. And this is nothing. Just go under the interface and put one command fair queue. And if you have already weight set, then it is going to be weighted fair queue. All right. So what are the things you learned? We have three types of marking. One is CoS, another one is IP precedence. These both have got only 3 bits, whereas DSCP has got 6-bit. So you got 64 different markings. What else we learned? CoS is layer 2 QoS, IP precedence and DSCP is layer 3 QoS. Now what is next? Let's go to the lab. Now this is the topology. You see the scenario. I already have the reachability between R1 to R4. And what else you see? The markings. I would like to do marking like this. I would like to mark all the telnet traffic with this, all the ICMP traffic with this, and all the voice traffic with EF. Assuming that 4444 is a telephone, IP telephone. It's an IP telephone. Now any traffic going to this address need to be marked with high priority, EF. And if it is telnet from here to any of this address, it should be marked with this. If it is ping, it should be marked with this. So what I'm going to do is, as the traffic comes here, on this interface, I'm going to mark these traffics. We classify telnet traffic, ICMP traffic, and voice traffic, and we mark it. That I want to show you first. Okay, I would like to show you that first. Let's first try to ping. Actually, the quality of service configuration is already there in place. But before that, I want to show you reachability. Then I will show you the QoS stuff. Ping. If I ping, then OSPF is good. It'll ping because just now I turned on router 4, the convergence. Go to router 3 and check OSPF neighborship. I can see neighbor with router 2 but not with router 4. Why? Show IP OSPF interface brief. OSPF is running on. Okay, now the neighborship has come. Go back to R1 again, try pinging. It's pinging. So I'm able to ping all the loopbacks on R. On R4, we are able to ping. What is next? As the traffic enters from R1 to R2, I want to match the traffic and attach the value. I have already attached. I want to show you that. Then I will show you how to attach. I go to Wireshark. There are various ways you can verify. I can show you in Wireshark first. Do you follow me?
Yes.
Okay. Now you see, once again I'm going to ping. See this ICMP traffic coming from R1. I would like to show you. See, when I open this layer 3, you can see it is already having DSCP 13. AF assured forwarding 13. See 001110. You know what it means. I explained to you the other day. Now that's what we want, right? For ping we said AF30. Now if I telnet, I should see AF42. Let me telnet. Telnet 4.4.1.1 and ABC username password 123. Now go and check the TCP packet coming from 1012. You see AF42. That's what I have written here for telnet. Now ping to 4.4.4.4 is like voice. I should see EF. Now what I'm going to do is I'm going to go to R1 and try pinging 4.4.4.4. And now I should see EF. See? Expedite forwarding EF. EF. So quality of service marking is already there. Now according to the marking, I have also given 20% of bandwidth to voice. Let me show you that. Show policy map interface F01. This is where I have set the reservations. Look at this. I have said if the packet is AF13, what is AF13? If the packet is ICMP, 2% of bandwidth should be given. That's one queue. This is the depth. This is the queue. Queue limit is 64 packets per second. And for management, which is nothing but AF14, I believe. AF42. AF42, where it is. See, AF42. If it is AF42, I have given 3% of bandwidth, which is 300 kilobits per second. Voice is EF. I have given 2%, in which so far this many packets have come because I was pinging. Because I was telnetting, 30 packet has come. Because I was pinging, 15 packet has come. So quality of service is already there, applied. And all those traffic which is not matched, the remaining bandwidth will be given. Now OSPF is matching here. That's how we got 69 packet. OSPF is running right. That is going with the default queue. Now, if you see the difference between the voice, the voice have got priority keyword, which means priority queue. Whereas the telnet, the management has got bandwidth. ICMP also has got bandwidth. These two with the default class map is called as class-based weighted fair queue. This one is priority queue. So priority queue and class-based weighted fair queue together we call this LLQ. What you are seeing is LLQ, low latency queue. Now, how do we do this? Let me show you. What I just showed you is on F01 interface. That is the outgoing interface. But on the incoming interface, I have marked after matching. Let me show you that. Show policy map F00. You see, on the incoming, I have matched the access list 144 and I have given marking set command. I have given marking. And I have matched the access list 145 and I have given DSCP AF42 marking. I have matched ICMP and I have given marking AF13. See, this is what I have done. So as the traffic enters, I mark. Before leaving, I give them bandwidth priority reservation. Now let me show you this access list also. 146, 145, 144. Show access list. You see, 145 is for voice. This is the destination voice. 155 is for telnet. 145 is for telnet. 146 is for ICMP. This is how we do. Now what I'm going to do is, I'll just keep the access list and I'll remove the remaining and I'll do and show you from the beginning. Only the access list I'm going to keep. Alright, so I would like to remove this. First of all, I want to know show run interface F00. I want to know the policy map. The policy map called in. I'm going to remove this first. Likewise, another policy map called out. I'm going to remove these two first. I'm going under the interface. No service policy map. We are going to do it again for your clarity. I'm planning to do and show you. So I'm removing. Done. What next I need to remove is the class map and policy map. Show run section class map. No class mapping. Oh, first I need to remove the policy map. It says it is being used, so I'll say show run policy map. No policy map in. No policy map out. That's it. Now let us put the class map command again and remove them. No. 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 Done. Now if you check, there is no QoS at all. Let me ping one more time and show you in the Wireshark. This time you will not see any marking coming. Go to R1 and do the same ping which you're pinging earlier. You see now the same packet I'm capturing. You don't see anything. DSCP nothing, CoS nothing, no marking. If you want, I can telnet and show you. Telnet ABC 1, 2, 3. Now last time when you checked, you saw some marking, but now it is nothing. DSCP CS6, I did not mark it, it is default class selector. We did not mark it. Okay, so we did not mark this. And now let me come out of this and ping the other one. Now this also should not have any marking. See, no marking. CoS 0. Okay, now what is next? This telnet, no, it will have 6 because it is management. By default for telnet and SSH it is 6. That's why it was showing CoS 6. Okay. Now, no prioritization. So if I type now this command show in router 2, we were checking some bandwidth reservation, but this time you should not say any. Show policy map on interface F01, nothing. F00, nothing. Okay, so I have removed everything except the access list. Show access list. You see, I'm interested first in voice. Voice is the packet with the destination 4444. So it is 144. What I do, I'm going to say class map voice match access group 144. If that match happens, not set here. It is in the policy map. Come out of it. Now again, class map. This is for telnet 145. Tel match access group 145 class. Next one is for ICMP 146. ICMP. I'll say ping. Never mind this word. Tamil people will get angry, but this is the favorite animal of China. I'm a Chinese today. So match access group 146. My daughter used to call me Peppa Pig when she was small. I used to enjoy that. Now, we have just classified. Now we are going to set the markings. So I say policy map. I'll say in Greece or any name, any name. Whatever. In Greece, wherever. Match the class voice set DSCP EF. Done. Next. Match the class tel set DSCP. What is it according to our plan for telnet? For AF42. AF42. See, you have a lot of options. I'm going with AF42. Next. Class, what is the other class? Pig. That's for pinging. Set DSCP AF, I don't know what value. 13. That's it. Now, what is the policy map name? Do you remember? Whatever. This whatever you need to apply on the interface. Let's do it. Interface F0/0. That's the inbound interface, you see. F00. And say service policy input. It's coming in. And the name is whatever. That is all. You have finished half of the QoS. Whatever the traffic comes according to the traffic type, the the marking is going to be done. Let me show you that. Are you ready to verify? Hello.
Yes.
Show policy map on interface F00. You see, it says if it is voice, see the service policy map name is variable. If it is voice matching this traffic, I need to do this. So far no packet has been marked because we did not send any traffic. For telnet matching this access list, it should set this. So far no packet. For sorry, this is for ping. If this access list matches, it should. So far no packet. This is for default for the rest of the traffic like OSPF. So far OSPF has sent 3 packets, hello packets. Now let's verify. Go to R1 and ping this. This is voice. I should see EF now. Go to the Wireshark and see, you will find EF there. EF, expedite forwarding. Now let us try pinging 4411. Now I should see AF31, right? AF31. Yes, AF13, AF13, not 31. F13 for ICMP. Now let us telnet ABC 123. Now I should see AF42. That's right, AF42. I should forwarding for, which means marking is happening, but the reservations is not done. Now if I'll go to F02, no, if I go to the class map, sorry, policy map, let's say out, say level, and say class default, okay, that is the default class. Actually I can say setter. No, go straight to the interface, no need of policy map. What I'm trying to show is weighted fair queue or fair queue. Okay, so without policy map, without class map, it is already marked, no? So you go onto the interface straight and say fair QoS. I'll just write one access list just for showing you the weighted fair queue. Access list 101 permit IP any. Now class default. And then I say match access group 101. And then go under that cell level policy map. And then say class default. Class default. And then you will see fair queue. You see? Because it has already got weight, all the traffic that is going inside will be considered according to the weighted fair queue. Without the weight, without the marking, we did marking. Without marking, if you enable this, it is simply a fair queue. With weight, it is weighted fair queue. Now, our aim is not to do weighted fair queue. Our aim is to do LLQ. So, I'm going to remove this default class. Also here, I'm going to remove that default class which I created. And also the access list. I do not want class access list 101. Now we are going to use those markings. For that, I need to write another class map. Class map voice match DSCP. Already we have marked EF. You remember for voice? I'm saying match that. Next, class ICMP match DSCP. For ICMP, what is the value we gave? AF13. This is already marked. I'm saying match that now. Class map MGMT management match DSCP. For telnet, what do we give? AF42. Now go to the policy map cell level. Policy map cell level. Match the above one. Match this voice, which is matching DSCP class voice. Then you see, I want to enable priority queue for this, so I say priority. And then how much you want to give in, you can give in percentage. You can also straight away say how many kilobits you want to give. I would like to say percentage. For voice, I would like to give 4% from the existing bandwidth. Sorry, from the total bandwidth. Next, class. What's the next class? ICMP. For ICMP, they are tiny packet. I just want to give 1%. But I don't want to use the keyword priority because only one priority queue you can have. Now I'm going to use the keyword bandwidth so that it goes to class based. In bandwidth, how much percentage? For this, I would like to give 1%. Next, class. This is for management. Again, bandwidth. This is another queue. Percentage. For this, I would like to say 5% bandwidth. Done. What is next is I need to apply to the outgoing interface. Interface F0/1 service policy outside cell level. That's it. Now if you go and see show policy map F01, hey, interface. I can see now so far no packet has been given this reservation. No packet has been given these reservations which I just configured. But after telnetting, I can see in management. So let me go to telnet. ABC 123. Now you try that same command. Under management, you will see a lot of packets. See, 28 packets got this reservation. And this much of bandwidth has gone through the queue. And this many packets. And for voice and wireless, it's still 0 because we did not. Voice and ICMP still it is 0 because we did not ping. So let us ping now. If you ping now, I should see under ICMP. Under ICMP, look at this. 570 bytes have used this queue. Now let us do the voice. Voice is destination 4.4.4.4. Now we will see a match in voice. Here it was 0 before. Now I should see here 5 packets consuming this much out of 4%. All right. Any question? What you are seeing is the real world QoS method that we frequently see called LLQ. LLQ will have a priority queue with the class-based weighted fair queue. Any question?